sometimes it can be useful to rearrange or rewrite equations. Sometimes the author will publish an equation in one expression, one version, and people will rearrange them for various purposes. For example, I might want to show that Einstein's equation describes a linear relationship. And to do that, I might want to put it into the form of a straight line equation, which is y equals mx. Now, if I wanted to treat 1 over c squared as the coefficient that describes the slope of a line, I could pull that out and put it in front of L, like so. M equals 1 over c squared times L is the exact same thing as this first equation. That's just one example. Another expression you might want to rearrange is the equation for Ohm's law, V equals I times R. Ohm's law deals with electronic circuits, describing how the voltage across an ideal conductor is proportional to the amount of current going through it. This original expression, V equals I times R, highlights voltage V because it isolates that variable and puts it all by itself on one side of the equation. This gives us the other quantities all together expressed as voltage. Now we could just as easily highlight R, for example, the resistance R, by dividing both sides of this equation by I, the amount of electrical current. And that gives us R equals V over I. That's another equivalent expression. This is similar to a process of solving an equation for some variable. You can apply those arithmetic operations to both sides of an equation to arrange it differently. Meanwhile, the two expressions still mean the exact same thing because they express the same corresponding relationships between numbers and quantities. Let's bring it back to Einstein's equation. We want to identify the quantity of interest and rearrange equations so they highlight the essential information. Mass and energy were equally relevant to Einstein's work. He just chose to write the expression in a way that emphasizes the change in mass instead of the emission of energy. If you take this equation and you multiply both sides of the equation by c squared, you get L equals mc squared. And that's starting to look like the most famous equation. Now, Einstein chose to use the letter L to represent the variable for energy, but people later started using E instead of L to label energy out of linguistic convenience, maybe. L and E refer to the exact same thing. Maybe this rewritten version became popular because people don't like dealing with fractions. I don't exactly know. Either way, the most famous equation in the world is a creative rearrangement of Einstein's original equation. Both versions describe the same relationship between mass and energy that lead us to the general conclusion that an object's mass is a measure of its total energy content. Thanks for watching. See you next time.